Again, thank you guys for inviting me to be on RATPAC. There was a FreeDV talk given a couple years ago by Walter K5WH, and back then we didn't have the new FreeDV mode and machine learning stuff that we have now. So if you guys have watched that talk, you'll definitely find that stuff's been improved for sure. But for everyone who doesn't really know me, I've been licensed since the early 2000s. Original call sign being KG6AOV. I did that whole thing where you get into the hobby like to start, and then like life happens and you get out of the hobby for a while. Um, so that pretty much happened all through college and a little bit after college until I moved into my own place actually, and then I started getting back into it. Went from tech to general to extra, and that's where I'm at now. Um, right now, I'm a software developer at a medical device company where we primarily do C and C++ programming and C and Sharp and Python thrown into the mix. And I do a lot of open source stuff in my very limited spare time that I have these days. Um, and FreeDV is basically what I spend most of my time on. As I mentioned before the talk, I am mainly the person who is responsible for the FreeDV application. And we'll go over what that application is, how to set it up, and how to get on the air later in the presentation. So for those of you who aren't exactly familiar with what digital voice is, like say, for example, you've never used something like DMR or DStar, um, basically it's kind of, from a technical perspective, it's kind of like your live streaming, but using the radio instead of a computer um, and the internet. So typically how that works is there's usually a microcontroller or a PC that takes your analog voice into ones and converts it into ones and zeros. And usually is some sort of analog digital converter, as I mentioned, or maybe your PC has a sound card. Um, and once that digitized audio gets into your computer or other device, there is a modem software that runs and it converts that back out into a form that can be transmitted over the air. And same thing, reverse happens when you're receiving. So it's that received signal gets converted back into ones and zeros, and then demodulation software on the device um, turns that back into an analog signal that you hear in your speakers or headset. So why would someone do this instead of just using sideband or AM or FM? Um, a big reason is because it typically takes less bandwidth than a similar analog signal. For reference, sideband is about 3 kilohertz wide, and FM is about 4 times of that, like 12 kilohertz or so. And depending on the digital voice mode, you can actually cut that bandwidth use in half or even more. And smaller bandwidth typically correlates with more power density, and that also typically correlates with a lower minimum signal to noise ratio. It's one of the reasons why CW tends to get out when nothing else does. Um, on top of that, just the fact that we're digitizing the signal adds some noise immunity. After all, if you only have ones and zeros to deal with, you have a lot of leeway into what's a one and what's a zero. But that's not 100%, of course. A lot of digital voice modes also do what's known as forward error correction. And depending on some trade-offs you make, you can actually correct a lot of errors in the transmission that way. Digital voice isn't a free lunch, though. One big disadvantage is your signal's either there or it isn't. So, and it's also known as the digital cliff effect. And one example of this is when the US switched over to digital TV from analog TV. A lot of people didn't have a Q5 signal to their local TV stations, rather, and but they were still able to understand what was going on. Maybe there was a little snow in the picture, or the audio wasn't 100% great. And unfortunately, that wasn't good enough. Once we turned off analog TV, a lot of those people couldn't receive any TV anymore. And as you can imagine, that ended up being a giant mess. It's gotten better now that people are mainly streaming their TV online now, and other factors as well. Digital voice also typically didn't sound as good as like the strongest FM or sideband signal. A lot of people typically complain that, say, DMR or DStar impart a robotic quality to the audio, so it doesn't sound is not really something that a lot of people prefer. You can still understand it, of course, but if you're comparing it to if you have a really strong signal, a lot of the time, like that stronger analog signal is going to sound better. There's also some additional challenges with digital voice on HF. For one thing, there's a lot less spectrum that we have available on HF, so we end up having to cut some stuff out that's quote unquote unnecessary. And typically, that's usually very low frequencies, like 500 hertz and below, or frequencies rather that aren't possible on single sideband. So anything above 3 to 4 kilohertz. We can't just cut them out and leave them out, though. You kind of have to reconstruct them on the other end, or the audio quality is even worse than it currently is. And there's various ways of doing that. The general case is actually pretty difficult, but if you know what you're going to be transmitting, like for example, speech, then there are some steps you can take to simplify that. And one thing FreeDV used to use in the past, or currently does use, is sinusoidal speech coding. So what that basically is, you're just sending the fundamental frequencies and what's known as voicing data. And the other end basically just takes that info and reconstructs some sort of voice out of that. And that's currently used in the codec 2 library that FreeDV itself uses. And also M17 uses codec 2. So for those of you who might not know what FreeDV is, FreeDV is basically a way of doing digital voice on HF. In the past, digital voice has typically been a thing that's mainly VHF and above. But FreeDV itself provides different modes and based on different band conditions. And these modes are narrow enough that you're not going to piss off every ham that's on HF. And on top of that, because they're optimized for HF, they're better able to handle like typical HF propagation, like fading and so forth. FreeDV also provides a way to use digital voice with your existing radio, so you don't necessarily have to buy anything extra. If you're already doing other digital modes like FT8, then you're likely able to use FreeDV now without having to buy anything extra. So for some history, for those who aren't familiar, originally started out with a program called FDMDV back in the mid-2000s. And at the time, it used a commercial codec, but the thing is that the company responsible for that codec didn't say that we couldn't use it, but also didn't say that we could. So it kind of operated in this gray area where hams were playing with it, but they didn't really have any idea whether that was going to be a thing long term. And then, of course, things happened, and eventually that company said no, that we couldn't use that codec anymore, and that pretty much killed the project immediately. In response to that, David Rowe VK5DGR over in Australia created a open source digital voice library called Codec 2. And it started out with one mode in there, but over the years, more and more modes were added. And these days, there's a bunch of them ranging from 700 to 3200 bits per second. M17 typically uses the higher end of that range, mainly because there is more spectrum and bandwidth that's available on VHF and UHF. And FreeDV typically ends up using the lower end of that range. And as mentioned, FreeDV uses this Codec 2 library as well as the M17 project. And it was all nice, but though FreeDV had a few issues. For one thing, it shared the same disadvantages as existing digital voice modes, where you still had that same sort of robotic type audio quality. So it didn't sound that great. And because it was designed to run on HF, we had a lot less bandwidth and bitrate available, so that robotic quality basically became even more of a problem. And on top of that, it wasn't great at all voices. Some voices sounded a lot worse than others. So I'm going to go ahead and play an audio sample of what FreeDV was like a couple years ago.
It's quite obvious. It's right behind the 30-foot tower, 30-foot mast. You can crank up so I can maintain the antenna I can lower it to the top.
So as you probably were able to hear it, it still had that same sort of robotic type audio quality. Wasn't necessarily the greatest that is possible for a digital voice. And besides those issues, in FreeDV itself, you had a lot of different modes to choose from, and they were all optimized for different HF band conditions. And just the fact that there were a bunch of choices to choose from made it difficult for new users to understand, because they didn't necessarily know like when they should use what mode. And as a result, most users just coalesced around like one or two of the available modes anyway. So that kind of negated the point of all the other modes. And then there were some users where signal noise ratio still had to be fairly high in order to be able to decode any FreeDV in the first place. So that limited the use of FreeDV. So, and fortunately, there is a solution for that in machine learning. For those of you who aren't familiar with what machine learning is, it's basically a way for a system to generalize new stuff based on what it was trained with. And typically, in order for this to work well, you need a lot of training data. So, for example, in our case, you would need tens or even hundreds of hours of audio. And the fact that you're training and it needs a lot of math, and most of that's matrix multiplication, which until very recently, it wasn't really possible for the average user to use. There was machine learning stuff before a couple years ago, but it happened to be in like giant data centers, which I don't know about anyone else. I don't have access to a giant data center with a bunch of graphics cards. But these days, you can do AI and machine learning type stuff on graphics cards you can buy from the store. And even if you don't buy a new graphics card from the store, there's stuff like ChatGPT where you can just go to a website and just ask it a question and it comes back with something. And in the near future, there's a lot of embedded microcontrollers that are coming out that have AI optimization and like AI specific instructions, or even just specific like coprocessors that are optimized for machine learning type stuff. So we might see like a lot of machine learning stuff get pushed down into smaller and smaller devices. So that's something we'll have to pay attention to for sure. So that all sounds cool. But how is that relevant for digital voice? For one thing, machine learning lets us better model how speech should go out over the air. So a lot of the stuff like silenced speech coding, for example, was developed by humans and based on our current understanding of speech and HF propagation or radio propagation in general. So it's very possible it's not the most ideal because humans aren't perfect, of course. So with machine learning, we can actually give it a bunch of training data, and it comes back with something even better optimized, and for say HF, for example. And on top of that, machine learning also could help us better decode a digital signal over the air. So for example, we could pass that like a perfectly clean 100% no error digital signal through simulations of various HF propagation conditions while we're training it. And then we iterate that model based on the real world. And over time, we can use that modeling to help basically produce a better decoder. And that could potentially get us down to lower minimum signal noise ratio as an example. And in fact, there's been some effort in doing machine learning based codecs. A lot of it has basically been done by the big tech. For example, Meta/Facebook came out with encodec and MLOW, and then Google came out with Lyra. And these all sound really good, but they also take a lot more bandwidth than what we have available on HF, so we couldn't just slap them in and call it a day. So we still needed something more. And that brings us to the new FreeDV mode that I'm talking about today. It's called the radio autoencoder. And what this basically is we take the various voice features such as pitch, and we generate PSK signals that are sent out over the air. And then the decoder basically converts that back to features that we just passed to the voice codec that we're using. And right now we're using the Fargan voice codec, which is developed by the Opus project. But theoretically, any codec that deals with voice features can be used with this. And you might be interested in how RAID sounds versus single sideband. I'm about to play a couple of audio samples. The first one is going to be a single sideband signal that's pretty deep in the noise and kind of difficult to understand. And the next one is going to be how that sounds when encoded with RAID instead. So first off, here's the sideband signal. And then next is the RAID signal.
CQ, CQ, CQ. This is VK5 Delta Golf Romeo, Victor Kilo 5 Delta Golf Romeo. Calling CQ for UV 2020.
So as you were probably able to hear, there was a lot of hiss and background noise on the sideband signal. You could still understand it because humans are actually pretty good at filtering that out. But I I don't know. I personally wouldn't want to listen to that for an entire contest weekend, for example. Um, and Raid, as you were able to hear as well, had no background hiss and it was basically Q5 solid copy. And so this sample was recorded back in June 2024 based on some semi-automated testing that we were doing. And if you're interested in hearing about that, or reading about that rather, I have a link up in the slides. And this is also available on the FreeDV website if you go clicking around there. And the best part of it is this wasn't the best we were able to do. We've made a lot more tweaks and updates since then to improve that further. So for those of you, you might be like getting really excited about FreeDV now and wanting to try it out or retry it if you've tried it before. And in order to basically get on the air with FreeDV, basically most people download the FreeDV application available at freedv.org. And we have Windows binaries as well as for Mac. And if you're on Linux, you can pull the source code down from GitHub and build that yourself. The FreeDV application requires two sound cards. But that doesn't sound as bad as that's not as bad as it sounds. As I mentioned, one of those sound cards is likely going to be the same sound card you're using for, say, FT8. And the other one is likely going to be like some sort of headset, Bluetooth or USB, or even just like a sound card built in your computer already. And I'm going to turn off the slides real quick, and I'm going to go through the website, and we're going to show you where to download this latest version of FreeDV. So if you go to freedv.org, I'll make the font a little bit bigger for you guys. And you click on the download link up here. It will go down to the kind of like in the middle of the page, and you'll find the latest FreeDV installer for Windows and for Mac OS. And you can just click on, most of you are probably using Windows, so you can just click on the Windows link and it will download the installer. And then once you download the installer, you can go ahead and double click on it like you normally would, and then go through the installer and install it on your computer. And likewise for Mac OS, it works just like any other Mac application. It'll download a DMG file. You double click on the DMG file and then it'll create a drive and you can drag the FreeDV program from there to your applications folder. So, and then once that's installed and you start FreeDV, you'll get like the easy setup dialog box. And let me go ahead and stop the slides again. I'll go ahead and push stop here, and I'll show you what the easy setup looks like. Usually it'll pop up the very first time you run the program, but if not, you can go to Tools and Easy Setup. And what you'll see here is basically a simplified setup that's optimized for the most common use case, where you typically have one radio device and, say, potentially a separate device for your playback and record. So in this example here, I have it set to VB cable because I'm running a Flex 6300. And then I have it set to Zoom audio device, but you can set it to pretty much whatever speaker headset you're using on your computer. And then likewise, you can set whatever headset you're using. So right now I'm talking to you over Bluetooth, so you can set it up to use a Bluetooth headset. And then you can also go ahead and set up your radio control here. So we support Hamlib and Serial PTT here. And basically it works like any other program that uses Hamlib, like WSGTX. You can go ahead and choose the model rig that you're using. So I'm using a Flex 6000 series. And then you can choose the COM port here, or you can, I'm using TCP to communicate with the radio. So you can do like localhost : whatever the port number is. And once you have that set up, and you have the audio devices set up here, the cool thing about the FreeDV program is you can go ahead and push the test button. And if everything's set up properly, which it is here, you can see that it's transmitting a constant carrier. So if you do that and notice that it's actually transmitting something, actual power output, then you know you have everything set up right. And then for serial PTT, just for completeness, you can go in, choose serial PTT, choose your COM port, whether you're using DTR, RTS, and all that fun stuff. And then finally, you can choose enable reporting. and that's highly recommended. We're going to talk about how to find contacts on FreeDV later, and enabling reporting is a large part of that. And once you can check this checkbox to enter your call sign in grid square. In this case, I put my call sign in and DM12KW, which is where I'm currently living in San Diego. So you can go ahead, and once you have that all set up, you can go ahead and push OK, and you're pretty much, for most cases, you're pretty much good to go. But there are some setups where easy setup isn't sufficient. And as you've probably noticed here, there's a couple advanced buttons. One advanced button is for the sound devices. So you can go ahead and click on advanced if you need like more advanced setup. And you can go in and choose each sound device individually. So for example, this is a fairly straightforward setup where I'm using the same device for both input and output on the radio. But say if you're using different virtual audio cables, for example, because you're running some sort of SDR, you can choose like a different SDR, or different virtual cable for receive and different one for transmit, for example. And then you shouldn't have to do this, but there's also a sample rate set up here. You usually just choosing the default one is fine. And then for this advanced config, you would basically just you would go through both of these tabs, and you would start at the top, for example, whatever sound device for your radio. And then the bottom is whatever you're using for your headset or speakers. And then in the transmit tab, you would basically use whatever you're using for your microphone at the top. And on the bottom is whatever you would be using for your radio. And in any case, once you've finished that, you can push OK, and it'll reflect in the easy setup here. And then there's also advanced setup for your radio control. So you can go ahead and push advanced if you need that. And here, it's basically a similar sort of settings, like you can do cat control via hamlib or serial port PTT. But the nice thing about FreeDV is it also supports some foot switches. And to do that, you can just click Enable PTT Input and choose whatever COM port is your foot switch is on. And once that's set up, you can just push on your foot switch, and FreeDV will go into transmit. And I think I have it in the slides, but on Windows as well, we support OmniRig. So you can just, if you're using OmniRig, you can just enable OmniRig and choose your rig ID, and it'll basically do the rest. So that's pretty cool there. And so yeah, once you're done with easy setup, you can go ahead and push OK. And just for completeness, you can get back to each of those configuration advanced configs by going to the tools menu in either audio config or cat and PTT config. And then there's also options. You can go in and manually configure reporting, for example. But easy setup should automatically take care of this. But I figured I'd add that there for completeness. There's also some rig control settings that might be relevant depending on your radio. One big thing is a lot of radios don't really handle USB-D and USB-L all that, or LSB-D all that well. So you can choose to have it just use normal upper and lower sideband. You can also disable mode changes entirely and just either do frequency changes only, or just have it only take control of PTT. So in case you have a radio like that, tools rig control inside tools options is probably a good place to go. And then there's one more setup that's really good to do. And to do that, basically you would just go, well, first choose RATPAC up here, because that's the mode we're talking about. And then go ahead and push start. So the final thing you'll need to do is you'll need to make sure your transmit audio is fine. So it's hard to demo this here, but like, say for example, I go ahead and push PTT to transmit. You'll want to make sure that you're not overdriving. So you, just like with other digital modes, you don't want ALC to show up on the radio. And in the Flex, ALC shows up a little bit differently. So you don't want the level to be basically at 0. You want it to be a little bit less than 0 to make sure you're not overdriving. And on top of that, you want to make sure your mic levels are good. If you're overdriving your mic, you're not really going to sound all that great. And it depends on the operating system there on how to set that up. So I'll go ahead and ID since I've been transmitting for a couple minutes. K6AQ. So now that we're done with sorry, I forgot to mention, we also have a TX attenuation option here if you need to adjust your transmit levels. So like I have it set to 0 because with my setup that's okay. But for a lot of radios you'll need to like lower this to some amount, and the exact level you need to lower it down to is up to experimentation. So definitely give that a try. Um, so we already talked about the audio levels. So we'll go back to the slides real quick. Actually, before we do that, let's see if so I'll talk more about the FreeDV reporter in a bit, but as you can see, someone was actually able to receive me. So just and someone looks like they're transmitting right now. So unfortunately, I'm not seeing anyone. But what I can do is I can go ahead and transmit the my voice keyer. Oh, that's something else I can demo as well. Voice keyer is a really nice feature that lets you just send out a CQ message. So we'll go ahead and we're transmitting the voice keyer right now, and we'll see if I'll see if I can bump up the power a little bit too, and see if that helps. Yeah, like I said, I'm hoping this well, it might be band conditions. So we'll see if anyone else is able to hear me right now. It looks like WA5QPZ is picking me up a little bit more strongly now since I bumped up the power level. So we'll see in case they're on this talk, we'll see. I'll stop the voice here and see if I hear anything back. If not, it might just be band conditions. So and unfortunately that happens sometimes. But what I can do is let me see if I have it on here. Yeah, WH2TOP is transmitting, but I'm not seeing him. But what I can do is I can play back another a little bit of a longer audio sample. And basically this is from a QSO that I had with K0PFX over in St.
It would
Louis.
actually help if I turned on my microphone.
And what you're hearing right
Sorry about
now is
that.
my end of the conversation. So it's
So
going to show up a
hopefully,
lot more
now
strongly.
you're hearing me. You were coming
And I
in at
used
a
the
SNR
record option here
20-ish for
to
me.
record this.
So definitely coming on clear now to H200 10 around K0 PFX K6AQ.
Yeah, very good, Mooneer. About the strongest signal I've ever seen from you. Yeah, you did quite well. Hope all's well out there in California. You haven't burnt the place down yet. So warmed up here. But we still got a lot of winter yet, so.
So yeah, just another sample of what that sounds like, just to get you guys excited. So we'll go back to the slides, and I'll keep this running in case anyone comes back.
Sounded like
So a question that comes up occasionally is whether FreeDV itself is actually legal. And I'm not a lawyer. I don't really play one in real life or on the internet. So I am not an authority on this. And additionally, what I'm about to talk about is pretty US centric. If you're not in the US, you definitely want to contact someone who knows more about this than I do. But I can't tell you what the AWRL has mentioned in the past. And basically in the QEX from May and June 2000, they had an article called Practical HF Digital Voice. And there was a sidebar where they addressed this exact question. And at the time they considered digital voice. Oh, so I think that was WA5QPZ. Thank you for coming back. I'm currently giving a RATPAC talk right now. So I'm basically doing a live demo over the air of FreeDV. And I got about 50% copy, but it looked like there was some deep fading. So but whatever did come through came through loud and clear. So hopefully you're able to hear me. So K6AQ.
He's on the presentation now. He's watching you and he's copying you.
Awesome. So yeah, we'll go back to the slides while I was talking about. So basically, ARRL considered digital voice as having the emissions designator Juliet 2 echo. And I don't know if anyone's dealt with emissions designators. They're not the most like obvious in the world. But basically, in short, the J stands for a single sideband, and 2 is basically a single channel with digitized information on it, and E means it's mostly voice that's on that channel. And if we accept the ARRL's reasoning, that makes it a phone emission per Part 97. And because it's a phone emission, it also governs where DV can be used on HF. In short, basically it can be used anywhere that we can do sideband on HF, except for 60 meters. Currently in the US, FreeDV would not be legal on 60 meters, basically because 60 meters itself is regulated a lot more strictly since we are sharing it with government stations. There's some talk about harmonizing our allocation with the rest of the world, and that might allow us to use FreeDV on 60 in the future. But for now, in the US, 60 meters is not legal for FreeDV. There's also the question about whether FreeDV itself is actually J2E. One reason for that is because you theoretically don't need a sideband radio to transmit it. Like, you can just build a device theoretically that transmits FreeDV directly. And even if it wasn't J2E, Part 97 does give us a lot of leeway in what's considered a phone emission. So personally, I'm not too worried. But again, if you're at all concerned, talk to your relevant regulatory authority or someone who knows more about the law than I do. And besides that aspect, the same like practices we always do on the radio are still apply. So you still need to ID every 10 minutes and at the end of the transmission. Not always run 1500 watts when you don't actually need it, for example. And a lot of these are actually FCC rules as well, so you should already be doing them. And on top of that, I always like to add a reminder that you should be listening before transmitting. Because FreeDV is not exactly that common, it is easy for someone to just mistake it as, say, just local RFI, for example, and just try to transmit right over it. So definitely, if you're normally using sideband, definitely take extra care with the normal FreeDV frequencies before you transmit. And likewise, for everyone using FreeDV, make sure there's not actually someone already using the frequency, so you don't accidentally step on them. And then FreeDV also has some conventions that we've agreed on. And typically we follow the same conventions as analog voice. So upper sideband, 20 meters and above, and lower sideband, 40 meters and below. And we do that because I forgot to mention here, but there's also a analog button here. So you can go ahead and click on that and basically hear the band noise. And if there's a sideband contact, you can hear them as well. And that's pretty much the big reason why we want the same conventions as normal sideband, so to make it easier to determine whether someone was on the frequency. If we just used upper sideband for everything, like a lot of other digital modes, that makes it a lot more difficult to determine that, and increases the potential of stepping on people. And we definitely want to be good stewards of the ham bands for sure. And on top of that, a lot of our activity is on 14.236 megahertz. So a little bit above the sideband, or rather SSTV, plus or minus a little bit depending on who's on frequency. But we don't only operate on 20. For example, we operate on 40 meters as well, typically 7177. And then 28.330 on 10 meters is a common frequency too. And another thing I forgot to show, once you set up FreeDV for the first time, you'll see the current list of calling frequencies in this drop down here. So that gives you an idea of like where everyone is at. Since we also have people who've used FreeDV on QO100 in Europe, we also have a calling frequency for that. So that's why there's this 10 gigahertz one here. But as you can see, there's various frequencies on 80, 60 meters for people who are not in the US, 40, 20, etc. So this definitely gives you a good idea of where people are operating. But also, I'm going to go, since we're at that slide anyway, I'm going to go ahead and talk about FreeDV Reporter as well. So the nice thing about FreeDV Reporter, it's basically our official spotting service for FreeDV. So what you can do, consists of a website as well as the built-in client in the application. So right here, I have a built-in FreeDV reporter client open, and it's showing the same, similar to what you would see if you went to the website. So it has a list of people here, and you can see the live status of what people are doing. So for example, WU8F is currently transmitting, and same thing with JA4ECX, just on different bands. And then if someone was able to receive, then there'd be, by default, there's a blue shade that they turn, and they'll also report the call sign here. As you can see, WA5QPZ received me earlier. That's why my call sign's right there. And then you're also able to do a custom message, and you can do that at the bottom. Right now, I set it to RATPAC talk because obviously I'm giving a talk with you guys, but I can set it to whatever. And it also supports languages other than English, so you can see a lot of the Japanese users have Japanese characters in here. And then another cool feature, let me see if I can demo this since WA5QPZ is on. I'm going to go ahead and switch over to 17 meters, which I just did. And I'm the only one on 17 right now. So, well, I want to talk to someone I want WA5QPZ to go to 17 as well. So what I can do is click on WA5QPZ here. Oh, or I guess oh, actually, I think WA5QPZ already switched over, so that's why it's not working. But I can go to K0PFX, for example, and I can click on request QSY. And what this basically does is it sends a message to K0PFX requesting that he switch over to 18.118, which I'm currently on. So if he sees that and clicks accept, then his frequency will switch over. It looks like WA5QPC switched back to 20, so I'll go ahead and do that so you can see that happening. As you can see, we've requested. So hopefully WA5QPZ saw that and we'll switch over. And then while that's going on, I'll go ahead and show what the FreeDV Reporter website looks like as well. So the website is qso.freedv.org, and it's linked on the main FreeDV website as well. And as you can see here, it has a lot of the same info as the built-in FreeDV Reporter client. And it does similar sorts of things as well, like it'll change colors based on whether someone's receiving or transmitting. And you can see their call signs of whoever they received as well. FreeDV Reporter website also has like a chat function. So it kind of works like IRC or Discord if you guys are familiar with those. So you can go ahead and click on, type your call sign in, push login, and then you can go ahead and start chatting. So for example, I just sent something into this chat room, and it's only me and K5WH on here. But the nice thing about this chat as well is it's linked to our Discord. So I can go to the FreeDV Discord channel, and you can see this FreeDV Reporter channel here, and you can see that whatever I type in here basically just goes into the Discord. And likewise, I can type back into from Discord, and it shows up here as well. So that's cool for sure. So WA5QPZ, I'm switched over to 18.118. So as you can see, he went ahead and accepted my request and is now on the same frequency that I am. And it looks like WA5QPZ is coming in. And that band is, so 17 is working a little bit better. But I'm running a mag loop, so I need to retune real quick. So this is a hardware device that I built to tune my MFJ mag loop remotely. So it's basically ESP32 on it with like an H bridge, and it's a simple web interface, and I can just click on like buttons to like adjust the tuning. In a sense, basically plus or minus 12 volts, depending on what buttons I push. So kind of not tuned, but close enough. So SWR is a little high, but as you can see, 17 is working a little bit better between me and WA5QPZ. we'll go ahead and stop that. And then next thing on the slides, another way you can find contacts on FreeDV besides FreeDV Reporter is the basically PSK Reporter. And it works pretty similarly to like say for like FT8, for example. It's just that you can just choose the FreeDV drop down here. And right now, if I just tell it to view everyone in the last 24 hours, you can see there was a lot of activity in Europe and Japan as well, and a fair amount of activity here in the US too, and in South America. So it pretty much gives you a pretty good idea of like how propagation's going, and probably might help if you have like a beam, for example, the point two for the best contacts. So and then we also have that Discord that I brought up a little bit, but the Discord is also nice for finding contacts. So it basically kind of works like IRC. It's basically a chat. You can go ahead and type stuff, just like any other chat. And you can also get support in like any sort of like help with FreeDV as well. And as you can see, we also have some interfaces to other services. So QSO Finder, for example, is basically a text feed from PSK Reporter. And FreeDV Reporter, as I mentioned, is a link to the FreeDV Reporter site. And IRC, we also have an IRC channel as well on the Libera chat network, if you guys are familiar with IRC at all. And so we'll go back to the slides. Another really cool way of finding contacts is by taking part in FreeDV Activity Day. This is typically the third weekend of every month. So it's not going to be this coming weekend. It's going to be the weekend of Dayton, so next weekend. But we do this every month, so just come find us on every third weekend, and you'll find a bunch of people to talk to then. And typically this happens between 12 a.m. Pacific on Saturday morning or 700 Zulu, or 800 Zulu, depending on whether daylight savings is in effect, and 11:59 p.m. on Pacific on Sunday, or 6:59, 7:59 Zulu the following Monday. And it's kind of designed in the same sort of style as, say, the JS8 activity day. So not a contest. It's kind of just like a time for people to have fun with FreeDV and find people to chat with for sure. And it might look like we're done and we're like not developing anymore, but there's actually a lot of work still to be done. One big thing is we'd like to integrate the RAID mode in the radios at some point. And in the past, we've done some integration efforts. We've designed external hardware devices that interface with radios to allow that, for example. But the existing devices we have designed aren't currently capable of running RAID. They can run our existing FreeDV modes perfectly fine, but not RAID, unfortunately. So that's something we'll have to talk about over time. And then the reason why we would want to be integrated inside radios is basically ease of setup and ease of use. Like it's a lot better to just turn on your radio, push the FreeDV mode on your radio, and just start talking, rather than having to deal with audio levels, sound cards, and so forth. And if you happen to have any connections with any radio manufacturers, I definitely would love to hear from you. And maybe we can talk a little bit offline after this talk about that. So we're coming up on the end of what I have to say, at least. And if I don't get around to addressing your question, you can always email me, mooneer@gmail.com, or you can go on to the Discord, the QR code on there, or just find a link at freedv.org. My username on there is The Mind Is Watching, but I also have my call sign in there, so you can find me that way. And if you guys happen to be coming to Dayton, we have a booth at Dayton, booth 1909 in Building 1. So come chat with us there too. And I'm also going to be giving a shorter version of this talk at Dayton as well. So with that, I'll go ahead and stop sharing and open it up for questions.
Okay, K8HY raised his hand. Go ahead.
Did you call for KHCHY?
I call for K8HY.
HY. Okay, that's me. Okay, I've been using digital voice FreeDV since last September, and then got on to RAID back in December. I love it. I just wish more people were doing it. I have one small suggestion, Mooneer. I use a remote tuner with my ICOM, and it would be very helpful if there were a radio button when I'm in RAID mode and I want to make sure that I'm all tuned up with my tuner is got minimum SWR and all. I need to send out a sine wave. That tuner will not react to the set of sine waves or the spectrum that you transmit normally. So a button with a power level control that would let me turn on a tune signal that I could regulate the power so it would be relatively low level would make an excellent maneuver for me, make things maneuvering much easier. But I love what you're doing. I just wish more people were listening, were using it. Thank you.
Oh yeah, for sure. That's something we can keep in mind. That should be fairly straightforward, but it depends on how much time availability development team has for sure. In the meantime, it's not going to give you power control really, but like there is that test button easy setup that you can go to and push the test button, and that does transmit a constant carrier.
Yes,
Not ideal, of course, but like that is something.
Yeah, the easier thing on my ICOM is just for me to switch into CW, send a CW signal, and it's a convenience thing. So it's one of those things. It's not very necessary, but it would make things convenient for those of us, especially the ones that are moving around and changing frequencies occasionally. Okay, appreciate what you do.
Anybody else? Barry, how we doing in chat?
We're good in, hold on, someone just posted something. Are the frequencies LSB or USB?
So I mentioned this a little bit earlier in the presentation, but we follow the same conventions as analog voice. So 20 meters and above is upper sideband, but 40 meters and below is lower sideband.
Okay. Anybody else?
That's everything in chat.
Okay, thanks, Barry. I don't see more hands up. Great presentation. Appreciate you coming on.
Barry has his hand raised.
Oh.
Nope, I'm just clapping.
Oh.
No, Barry, I'm BK3BR2.
Okay.
Okay, go ahead, Barry.
Mooneer, is there any chance in the future of being able to hear better low signals like they do in Whisper and FT8, where they can go down to -26? I don't expect that far, but is there any chance of getting down to say minus 5 or minus 10 dB, or is that just a bridge too hard to cross?
I've seen decodes as low as -5 already. I think there is room to go down a little bit further, but as you said, I don't think we can go down to like -20 or anything like that.
Oh no, thanks for that. And there's also been the question going around for a long time, and I think you answered it, that it's audio, but is it digital or audio? I know down in South America, they want to put it down with the Morse code and FT8 and signals down there. And here in Australia, we like 7177 or 7180. Jose and I usually come up on 7180. So I guess that's always going to be a bit of conjecture as what it is.
Yeah, that's a question that comes up occasionally. A lot of that is really down to regulatory stuff. Like for example, the US is one of the few countries that actually regulates by mode and not say bandwidth, for example. Like if the US regulated by, like say, any signals wider than like 1 kilohertz are on the upper end of the band, and anything low, like 500 hertz or whatever, on the lower half of the band, as an example, not suggesting we do that at all. But like, I think if we regulated by, like not by mode, I think it would be clearer as to what we would be doing. Like I imagine a lot of people would be operating say closer to like FT8 and CW and stuff, because it like intuitively, like, yeah, there is data effectively going out. So it does make sense to like transmit on the lower end of the band. But as it is now, my understanding is that at least in the US, it's recognized as a voice mode and not a data mode. That's why we operate on the upper half of the band.
Okay, thanks for that. Something else that might be worth putting on the .org website where you download the program is to tell people that if they are setting up RAID or the latest version, it does take some time, and to leave the computer online and connected. I know some people who download a program onto a memory stick and then go and install it on a laptop and then wonder why it doesn't work. Because when you run it, of course, it goes backwards and forwards to the internet, and the old versions without RAID would install very, very quick. But the RAID version can take 2 or 3 minutes to install, and it needs the internet because it's got to download a lot of stuff like Python and everything else that goes into it. And I just wonder if some people are getting caught by not leaving it connected to the internet for that period of time, or getting halfway through and saying, well, this is taking far too long, where the other ones were very quick. This is taking far too long, and then turn it off and finish up with a computer they can't use very well anymore because there's a lot of files open. I just wonder if something like that should be put on there, just to say that it does take a lot longer.
I can tell you that the next preview build of FreeDV will have like a message box that pops up in the installer that basically reminds people to keep it running.
Good idea.
While that's going on. Additionally, the long-term plan is to not need Python at all. The reason why we're using Python is that's when it was quicker to develop than that initially. But the long-term plan is to get rid of Python entirely, port everything to C, C++, and go back to pretty much not really having to download anything extra. I'll also add that on the Mac, because of how Mac applications work, we actually do integrate Python into the application itself. So if you're downloading it onto a Mac, yeah, the file, it downloads like a 400 megabyte download or something like that. But like once you download it onto your computer, you can just drag it to your applications folder and you're done. So you don't necessarily need to be online for the Mac after you grab the DMG.
Okay, Barry, there's some stuff in chat. What you got?
Yes. Dan once he said he has heard that FreeDV was supposed to be available on the Z BitX, but apparently you have to install that yourself.
Yeah, I've heard about that. I don't think that one, I'm not familiar with like how it works on that particular radio, but I imagine it's very unlikely that it has RAID support, because the ZBitX runs like a Raspberry Pi Zero or something like that. And in my experience, you need about a Pi 5 in order to run RAID comfortably. So I don't think there's enough processing power on the current ZBitX to run RAID at the moment. But that might change once we port over to we get rid of Python and port over to C. That might be different then. But if you're interested in using any of the older modes, that is definitely an option. And it might be worth playing around so you get a better idea of what the differences are versus RAID.
Either that is playing around.
We also have from Australia on.
Yeah, hi there.
That's everything in chat.
We got a lot of good showings here from Australia tonight. That's great. Okay, I don't see more hands up. How you doing?
Rudolph is waving his hand. You might want to say something.
Okay, good. You're watching that closer than I am. Hello.
Rudolph, go ahead. You don't have any audio.
Okay. Rodeo is no audio. Do you see video with him?
I see video, but no audio.
Okay. Let's come back to you. Anybody else got anything? Hmm.
Is it working now?
Here we go.
There you go.
Sorry about this. Here's Oscar Echo 3 Radio Papa United. My name is Rudolf. I'm coming from Austria, and I'm working on a university for applied science. And we have a small HEM group here, and we are very eager to promote this great thing, to promote RAID in Europe. And so my question is, are you interested to do this? We want to do this maybe in the HEM fair, which is in Germany.
I think there's been some discussion about like potentially some. I don't think it's going to be me doing it. I don't know who exactly, but like there's some talk about maybe presenting something on Zoom or something. Unfortunately, because of like family stuff, I can only really do like a couple Hamfests a year, and they're pretty much all in the US. So that's kind of like why I probably wouldn't be able to go there in person, but like something like on Zoom would potentially be an option, and that is being discussed.
Okay, this would be great.
Well, thank you very much for the question. Dave, NASBE, go ahead, take it away, sir.
Yeah, my question is about the idea that you have to have two soundboards to do transmit and receive. With a whoops, sorry, I've got this other thing ready here. Just a second, let me turn it off. So the question I have is that if you have a more modern radio, like I have an Elecraft K4, which has a USB codec that comes in from the radio and is bidirectional. And so, and then of course, I also have the sound card that's built into the laptop. So does that give me enough working along with using the virtual cable to be able to actually do transceive with this, or do I still end up having to get yet another soundboard?
No, for modern radios, you're pretty much set. Like one of the sound devices is going to be like a USB audio codec, typically, for example, or if you're using an SDR, like a virtual audio cable. And then the other one is likely going to be whatever you're already using for Zoom calls, whether it's Bluetooth, a USB headset, or a speaker and mic that's built into your computer or something.
Yeah, okay. Well, that's what I was hoping would be the case. I just downloaded the new dev version here, and I've got it receiving now at the moment. But and after we get done with this, I'm going to play around to see if I can get the transmit end of it working. So,
okay, that's what this is all about, there, Dave. Okay, Barry, go ahead. VK3.
Just for everyone, I thought I might come in and just let you know the way I use FreeDV, or currently use FreeDV. At present, just about every night, or 4 nights a week, I talk to LU5DKI Jose over in Argentina on 40 metres, and of course from Australia to get across to Argentina on 40 metres is not very easy. So I use SDRs, and the way I've got my computer set up, and it is only on one computer, I have a virtual audio cable set up, and be careful, it is better to pay for one, because I had a free one for a while and it kept giving ads all the time, and I wondered what the strange noise was coming through on FreeDV and why sometimes it would drop out. And once I paid for it, that didn't happen anymore. So from the browser, find an SDR. You can find them pretty easy, Kiwi SDR, and you just tune in the frequency, and then I link it to a program called a Voice Meter. Voice Meter is a free program, but if you pay for it, you don't have to go and click something on it all the time, and I can't remember what it is. But it has two inputs. Well, I use two inputs and one output. So the two inputs of that, one of them is connected direct to the radio, so that local stations I can just click a button on Voice Meter and it just drops in through that way. Or most of the time I've got it on SDR and it comes in through the SDR into FreeDV. And of course the output of FreeDV goes straight to the radio. Doesn't need any virtual audio cables. And most of the radios these days have got sound cards in them. And of course your computer's got a sound card, and I use a headset, that way I'm not annoying anyone else around the house. So that's the way I use FreeDV. Sometimes direct, but mostly via SDRs, and there are a number of SDRs all around the world. And the reception through them is just no different, than virtually no delay, and everything works as it should. That's enough from me.
No, that's great. Appreciate the input. There's a lot of people. You can see them taking notes. Good information. WA5QPZ, I'm not sure. You have your hand up or just resting it on the chair? Okay. Okay, looking around, like somebody commented in the chat, lots of VX tonight. This is great. We enjoy spreading the hobby far around here. Hey, anybody else got anything?
Too bad these don't count for RF contacts. It would be great. We've got 5 DX stations on here tonight.
You can't cheat. Okay. Well, and nothing more is in chat, right, Barry?
Oh, we're good.
Okay. Back to anybody else got anything at all? Great presentation. Thank you. Hope to have you come back again.
Tomorrow night we're doing a presentation on for the upcoming field day.
Yes, that'll be pretty good. I won't be doing it because I got my own thing going. But we do have a good team. They've done years past. They keep building on it, and I think you'll get a lot out of the field day presentation from them. Okay. Well, unless somebody's got some more, I'm going to say 73s and 7 to everybody, and see you on down the logbook, folks.